getting into a regular habit. I want to start with a couple slides. So what is open game data? I think most of you were here before, but essentially we're looking to create this community of researchers and practitioners to better understand the needs of people that work with data in games, to compile a better set of best practices and eventually build some infrastructure. We have a bunch of resources, so including the Open Game Data website, these office hour sessions, and a Slack where we talk about stuff. And so how are these sessions going to work? For the first 10 to 15 minutes, the presenter will share a project they're working on. In this case, we have Stefan Slater here. And then for the remainder of the session, we'll workshop with them to help them understand what they're working on, how they could potentially do things better, or what they might consider as next steps. The sessions are recorded, pending approval by the presenter. And hopefully we'll put them together as a big library that we can share among the community. So things to keep in mind, presenters are presenting on things that are works in progress, so that can take some courage to do. Things aren't necessarily going to be polished, ideas might still be rough or not fully thought out. That's kind of to be expected. Our goal here is to help the presenter understand and achieve their goals. You might come up with some of your own goals, that's great, but our goal here is to help them. And then these sessions are about learning for everybody involved. So if somebody mentions a concept you don't understand, feel free to raise your hand and ask for clarification. Or if you have an idea that you think might be useful, feel free to share that. And with that, I will hand off to Stefan.
Sure. Do we just want to start with the, I guess I can just do like a quick, 1 or 2 minute overview and then we can do the video. So my name is Stefan, PhD student at the University of Pennsylvania, working with Dr. Ryan Baker and David Gagnon on some aspects of the WAKE project at the Field Day Lab. In particular, what we're interested in is we're interested in understanding what optimal sequences of learning exist in the game in terms of how students move through different levels that exist within the overall experience. As part of that, we've needed to come up with a definition of what goodness is, what badness is, what are the events, the activities, the outcomes that we want to optimize around when we're thinking about what different sequences do we want to put these levels in. So what I've got to present on today is some early work that we've been doing on that in investigating the phenomenon of struggle in particular. So when a student is working in the game space, it's not productive for them. They look like they're not quite sure how to navigate and proceed through the current learning environment that they're in. And it looks like they're ripe for some kind of like intervention or other kind of, shifting of gears in terms of what they're currently working on. So this is a work in progress paper that we just presented at CHIPlay last week. And as part of that, I put together a 3-minute video about that process. Let me see if I can just queue this up and have it run. Wouldn't that be neat if that works right out the gate? So I'm going to share screen. What if I put you in your own separate browser window? Share screen. Screen 2. Share. If there's no audio, let me know. Audio good?
There's no audio.
It's not hearing it yet.
Can't hear anything?
Can't hear anything. Son
of a.
There's an option when you do the screen share, there's like a drop down thing to click share.
Oh no, all right, I'll go find it. I see it. It says share sound down at the bottom of the options that I don't look at. Like
optimized for.
Yeah, also optimized for video clip. So share.
Detecting when players are struggling offers opportunity for timely intervention to support learning and engagement. In this paper, we introduce the struggle detection model within the context of the educational game WAKE, Tales from the Aqua Lab. WAKE immerses players in the role of young scientists to solve research challenges in Ocean 4 research stations. The game progressively challenges players' abilities and knowledge, while providing contextual support through character interactions and breaking down extensive investigations into manageable tasks.
In collecting the ground truth label for struggle detection, we leveraged the text replay technique. This involves converting the log data captured during each gameplay session into human-readable segments, also known as clips, to facilitate both the initial exploration and the final coding process. A pair of human coders labeled these clips as struggle, not struggle, or bad clip if the clip was fragmented or degraded in some way.
We engineered 4 sets of features from the action log files to capture various aspects of gameplay behaviors or contextual information over time. Given that struggle is a complex outcome that arises from a sequence of actions, we aggregated all features at the task level. Subsequently, we applied 9 widely used classification algorithms to develop the struggle detectors. We evaluated the model performances and the degree to which it generalizes to new students using 5-fold cross-validation at the student level.
We explored a variety of feature selection and resampling techniques to increase model performance. Following these efforts, the naive Bayes algorithm demonstrated the best performance for struggle detection when trained and evaluated on non-resampled data, using features selected through forward feature selection. With an AUC of 0.635, the model demonstrated some capability in discerning instances of student struggle. In our paper, we also presented the results of the Shapley additive explanations, or SHAP analysis, on the chosen features, which is geared towards explaining the relative importance of individual features in predicting student struggle.
This model is our first step towards identifying factors that may lead to potential disengagement or frustration among students during their gameplay experiences. Moving forward, our effort will focus on refining the struggle definition and addressing the algorithmic biases that may be present. Ultimately, it is our hope that by identifying student struggles, we'll be able to offer them better gameplay experiences while also fostering greater knowledge and interest in the field of science when players engage with the game.
So there you go. To recap what we talked about in the video, we identified where students looked like they were struggling by doing human-coded reviews of log data. We constructed features around what students were doing in the gameplay environment. This included things like how long were they taking to complete particular tasks, how many attempts did they take on particular tasks, how did they move between different elements of the gameplay environment. And then we constructed machine learned models in order to try and predict when struggle actually happened based on those features that we constructed. And the outcome of that process has given us a model that's good but not great. It's good enough that we're comfortable using it in aggregate, so we can say things like, on this particular level, students struggled more than on this particular level. But it's not quite good enough for us to make student-specific predictions of this student is struggling at this moment in time, and we should generate some kind of intervention or send them to a different level as a result. So at least as far as what I'm hoping to get out of doing this presentation in the Open Game Data office hour, I'm hoping that we can brainstorm 2 things. The first thing that we can brainstorm is how can we improve this existing struggle model that we have? How can we better engineer features or better identify points where students are struggling? Because we could have issues with the fidelity of the labels themselves, where it turns out that struggle is just difficult to detect with human coding. But we could also have the issue of we're just not looking at the right elements within the data. And so if we wanted to have a feature engineering brainstorm, that would be totally fine. But the second thing I'd like to get out of this, and it's a bit of a broader question, is we landed on struggle as a thing that we would like to act upon in terms of figuring out what the optimal order of levels are to have students do in the game. There's no reason for us to think that struggle is the only or the best way of approaching that. And so if there's other outcomes that you think would matter for thinking about how you decide to send students through a different series of levels in this game, that would be really interesting to think about as well, as long as they're things that are actually like implementable, things that we can identify in the game space. And an example of that would be one of the things that we've been working on in parallel with the struggle detector has been a job switch detector. So finding the point where a student is working on a level in the game and they decide, you know what, this is too hard. I'm confused by this. I don't want to do this level anymore. I'm going to go and do another one. And they switch to a different level without actually completing the level that they're on. That's just another knob that we can turn in terms of thinking about where are students moving through the game efficiently, where are they engaged, where are they in flow state, and where are they falling out of that pipeline. Where might we want to think about the order of levels that they're doing in order to keep them working productively on that task?
Okay.
Is that good enough intro, you think, Erik?
Yeah, I think so. If people have any confusions about the game or anything, feel free to raise points. I think one of the things we've been realizing with these sessions is it really helps to like have a good understanding of how the game kind of works. And actually watching your videos is like there's way more stuff in Wake than even I knew was there. But one of my questions, which I think is getting a little bit at your second one, is kind of what do you mean when you say struggle? Are we saying like is there potentially a difference between like struggle with the concepts versus struggle with the game mechanics versus struggle with the UI?
Yeah.
And do you have a sense that maybe there are distinctions there?
I do, and that was also one of the really popular questions at Kai, for what it's worth. I do think that there's probably distinctions there. I know that the immediate distinction that we made was we didn't want to look at struggle with UI elements, because when we conducted this study, it was like a year and a half ago at this point, the game was still in active development, and a lot of times we would see a student struggling with UI elements, and we go, that struggle, unquestionably. But it was struggle with an element of the game that should be improved from like a UX standpoint. So we didn't necessarily want to predict it. We just wanted to pass it off to the development team and be like, hey, you guys should fix this because students don't know what it means. There, as far as like non-UX struggle goes, as far as looking at like, conceptual struggle, mechanical struggle, struggles with like literacy of either science or literacies in like a game space, I definitely think there probably are, but we run into an issue of class imbalances if we try to dig too deep on them. So the incidence rate for struggle that we found in the data writ large, and that's us just looking at, does it look like a student is struggling with any of those elements? Are they struggling with like, content learning? Are they struggling with like they haven't collected an organism that they know that they don't know that they need? We lumped all of that into struggle. And what we found is that about 10% of the cases that we looked at were coded as involving struggle. That's not like danger territory for thinking about a class imbalance problem, but if we were to try and break down all of the different types of struggle that might exist, I think we would absolutely run into some pretty significant class imbalance problems. We would thrash that problem way too much, and we might find that there's some really interesting, sorry, my cord is tied up on my chair. We might find some really interesting instances of, oh, like a student struggled here with like this particular kind of conceptual understanding, but we only ever found it twice in the entire data set. And it's simply not sufficient for us to build a machine learned model off of because it happens so rarely.
How much data was this?
This was 240 students, something like that. So like pretty good, approaching the upper limit of how much data I really want to code by hand.
Yeah, and I think related to that, another question I had, which I'd be kind of curious how you would handle this in the text replay method, is like I could see there being a distinction between like a moment of struggle and like sustained struggle. And so like maybe to some extent, I mean, it's a game, like a momentary struggle you wouldn't necessarily want to like adaptively act on.
Right.
But if it's like sustained struggle or a certain kind of struggle, maybe you would. And so how did you handle kind of like the time scaling or
yeah. So a lot of times when you build detectors like this, like in affect detection literature, a lot of times you'll see what's called a clip or like a window size. And in affect literature, that's usually about 20 seconds long. So every 20-second series of actions that take place in a learning environment will receive a code. So it'll be from timestamp 0 to 20 seconds, you get labeled for this affect. From timestamp 20 to 40 seconds, you get labeled for this affect. We weren't really able to do that in Aqualab for a couple of reasons. The first reason is because we're interested in acting upon struggle that happens as a result of particular level mechanics. So if we had a window or a clip that extended across 2 different levels, then it wasn't necessarily clear in terms of where the label was applied to the data, what the student had struggled with. They could have struggled with either or both of the levels, and it made it less actionable for us to actually figure out how do we now use this information to determine whether the student struggling on the first level or the second level inside this clip was the problem. And the second issue with that was that 20 seconds in like an intelligent tutoring system or something like that is a decent amount of time, but students spend a lot more time on things like an interactive game environment. The amount of time that exists within a level or like a task within Aqualab is much longer than it is inside something like the amount of time that you spend on a problem in an intelligent tutoring system. And so it was more difficult as a result to try and break down all of the specific things that are happening in that level in something as neat and orderly as like, you know, a sliding 20-second window. So what we ended up doing is there is within Aqualab, the goal of Aqualab is you're a young scientist, you're exploring different biomes, you are scanning organisms, you take those organisms back to your ship, you run experiments on them, you construct models about what's going on with the population dynamics in these ecosystems. And then once you've obtained all of that information from all these different processes, you then have a scientific argument with another scientist where you present your claims in support of or in refutation of a hypothesis. And all of those different processes inside the game are broken down into particular tasks. So what we chose to label our grain size, our unit size for looking at struggle was these individual tasks. So we could say on this particular element of this job, you struggled. On this particular element of this job, you didn't. And then on this particular element, you didn't. And that gave us a meaningful grain size in terms of what we wanted to look at for struggle, because it was very strongly defined by the elements of the game itself. So when we talked about when we labeled a student as struggling or not, what we were labeling is we were labeling a specific discrete portion of gameplay that had a meaningful interpretation in terms of going back to both what students are doing in the game and how the system expects students to move through the game, which we thought was very parsimonious in terms of figuring out what struggle looks like in this environment.
And struggle here is a binary flag. Did you
Yes.
think about doing like degree of struggle?
It would have been nice, but I've got this is the part where I'm actually going to put the onus on you to help me brainstorm in terms of how you would develop a sliding scale for struggle that a human coder could apply to data. Like, what's the difference? Imagine you make like a 5-point scale of struggle. What's the difference between a struggle rating of 3 and a struggle rating of 4 in terms of what a human coder is actually looking for in the data?
Well, I'd probably avoid numbers, first of all.
Okay.
I'd probably go with like high, medium, low.
Okay.
But
we'll call
I
it a
could actually
3-point scale
see-
then.
What?
We'll call it a 3-point scale then.
Sure, yeah. Or none, I guess, if you want to include an extra layer in there. But I could see like maybe you would want to know that like, oh, everybody's just sailing through this particular task or level or whatever. And like if a task was like 100% frictionless, wouldn't you kind of want to know that just as much as a task being too difficult? So it's kind of like that's kind of where I was getting at. Now, could you? I think you could probably tell the difference between like this kid is just totally like lost and poking everything to try and get out of this box, like super deep struggle.
Yep.
And I don't know what you'd maybe call like normal struggle or like conventional struggle or non-extreme struggle. But I also imagine that extreme struggle is probably even less frequent than your normal struggle is already.
I don't know. I'd have to go back and look at the data. I remember the instances of extreme struggle of just a student being completely lost as being really obvious, like really, really obvious when a student just does not know where they're supposed to be.
Right.
You will see them when you're working with the experiment tank, you are adding organisms to the tank to understand relationships that exist between different organisms. So you'll put kelp into an experiment tank, you'll put otters in, and you'll put urchins in, and then the sprites in the game will actually move around so that you can see an urchin eat kelp, and then you can see an otter eat urchin. And when that happens, you get a little prompt that you can click on, and that gives you a fact, and the fact goes and lives in your book. So that's the main mechanic in terms of like identifying evidence for what's happening in these ecosystems. And when a student is like irreparably lost, you will see them do two things in the experiment tank. You will see them rerun the same experiment multiple times, just adding the same organisms to the same tank, not getting anything, and then doing it again. You will also see them add organisms that are not related to the current biome that they're in, or even like the current section of the game that they're in. So there's like a bayou level and an Arctic level and a tutorial level, I guess, like the kelp environment or whatever. A student who is lost will be on like an Arctic job, and they'll be adding bayou animals to an Arctic tank. And you'll be like, this is you're off the mark here. Something has gone wrong.
Hmm.
So
So, go ahead.
Oh, yeah. So the other thing that I'd throw out just in terms of ways to think about sliding window on struggle would be, is there a way that you could account for like proportion of time on that task that was characterized by struggle, uh, or by the struggle behavior? So for, for any given task, there's some outcome that you need to have the task complete. And I could imagine, a student who, let's say, runs the same experiment a couple of times, they were struggling a little, and then they realized, oh, I was missing this one thing, and then they get it, and it only took them a couple tries, and that, as a proportion of the total time spent on that task would be less than a student who did the same thing over and over and over again. It was really, spinning their wheels, or it was like systematically trying every combination of critters until they got the right one or something like that. So I wonder if that would be another way that you could think about more versus less struggle, is like a greater versus lower proportion of the total time on task.
Yeah, I think for some cases that could definitely work. The first thing I thought of is that a student, if a student is struggling on a level, they are likely going to take more time on that level. And the nature of what they're struggling with could actually influence the overall amount of time that they take on a level. So in terms of thinking about like, let's just divide time spent struggling over total time on the level to get a nice like struggle percent. A student who's struggling with the experiment tank because they've collected all the organisms that they need, and they just haven't put them in the tank in the right combination,
Yep.
even if they're struggling, is going to finish a level faster than a student who has failed to collect a specific organism that they need and have to go all the way back to a dive site and find it and bring it back to the experiment tank once they've realized that's the issue that they're having. And so it's kind of like this weird confounding variable problem where the specific nature of the struggle that a student is experiencing can actually influence the overall time that they spend on the level. And so there's a weird dependency there. I don't know if there's a clever way that we could work around that or not, but I feel like you'd end up having like a weird collinearity problem if you were going to do it that way.
Sure. Yeah, and I guess it would sort of come down to the slippery nature of describing what struggle is.
Yeah. It's been remarkably difficult to pin down. Like everyone knows what struggle feels like when you're experiencing it, but man, when you have to like find where it happened post hoc and some data, it's really hard.
Yeah.
And one of the other things that got brought up at CHIPlay a lot was, why don't you just ask students if they struggled? Which in some respects actually could work pretty well, but in other respects, I don't put like a ton of faith into like self-report bias, but I feel like if you ask a kid if they're doing good at a video game or not, or if they're like having a hard time playing. That's one of those cases where you might get some kids going like, nah, everything is fine, even when it's not necessarily fine.
Yeah. Yeah, and I definitely come at that struggle question from like a bias in terms of the ways that I imagine using something like this. So I like to think about classroom tools and things that might be of use to teachers, which I think we should chat about a little bit more. We've got potentially a case where we might like to get into some struggle detection there, but I imagine that as a case where, okay, from sort of a teacher perspective, if I need to go and help a student out, get them unstuck, that proportion of time stuck, or the total amount of time stuck, is probably the key thing, more so than, you know, what is the cause of this, what is the nature of the struggle.
Yeah, absolutely.
I can imagine like the things that you've described of when can the game sort of prompt a student down another path, then the nature of the struggle, I think, becomes the key issue, right?
Mhm.
So I can see where there's a little bit of a disconnect there, just in terms of what the intended use is and how that affects what you think of as the important aspects of struggle.
I wonder what brainstorming you might have done with like that kind of. So say you make a real-time detector of struggle. What are you going to do with it?
I don't know, man. That's a David Gagnon problem. That's not a me problem.
But I can see like
It's
a couple
also like
different
a
dimensions. Like you could like kind of what you were talking about with the how you didn't want to do the UI thing. Those could also be what you do with this kind of detector. You get a data set.
Yeah.
You look at this task seems to be triggering a bunch of struggle. Maybe it's something with the task. Redesign it, redeploy the game.
yeah.
Or is it like the Nintendo thing where you're struggling so much and then it just pops up a little message of like, what if you just took a break for a minute, breathed or whatever, like calm down. Versus like a really hard solution could be, oh, we're seeing you're really struggling, we're just going to change the task on you and like force you down a different direction. And something that's maybe worth considering is how accurate your model needs to be is different for each of the solutions. Like
Yep.
we're just going to pop up a little thing to tell you to take a breather.
Oh yeah.
Like
Throw
a
it to
0.6
anyone.
AOC is probably great.
Yeah.
That's probably more than you need.
But if you're like, I'm going to force close you on this level and send
Yeah.
you somewhere else, that's a pretty drastic intervention.
You want a more accurate model then. So I think
Yeah.
that's kind of an interesting way to think about it. Of like, what could you see using this for? And then that actually kind of determines when you need to stop.
hmm
Uh,
Yeah, I mean, in terms of like what we told the NSF that we would do, which in a lot of ways is like the arbiter of what you should do on a project. What we told them we would do is we would identify sequences of levels that were better or worse for learning. It turned out to be kind of difficult to nail learning down, so now we're saying that we're finding sequences of levels that are better or worse for engagement or like other performance outcomes. So there's not really like a strong intervention thread to it. That's kind of like where my head goes when I'm thinking about practically what are you going to do with this thing. But in terms of what we told the NSF they were going to give us money for, there wasn't really like a super strong interventional component to it. So I think that's got a bit to do with the fact that like I just haven't really considered that stuff too much. But you're absolutely right in terms of thinking about like what the fail hard versus fail soft interventions are in these cases. And I do think we have like a model that's good enough for a couple applications. It's not good enough for the specific thing that we wanted to do, which is like for this student, what is the best level pathway to put you on for optimal learning? But it would be good enough to do things like, hey, you might be struggling right now. We're going to give you like a quick reminder that, you know, you can do it, or maybe try and take a break for a little bit and come back to it.
I mean, does the game really in its design kind of afford the ability to force a player down a particular route? Like, is it ever going to be more than a strongly worded recommendation and the player can just ignore you?
Hey, you could artificially limit the jobs that you see on the job board when you try and take the next one. It's going to make the game feel a lot more on rails. But so again, like, you know, catching people up on what the game looks like if you don't play it. You drive a boat around, and when you go to the helm of your boat, you have a list of all the different jobs you can take. So it's really it's pretty open-ended. It's very sandboxy. It's you can make whatever choices you want. You can stop a level and move to a different level anytime you want. And so what we could do in terms of like forcing students down those pathways is we could just artificially restrict the levels that are available at any given time, so that it's either like, you know, the best n levels for your current progression so far are the only levels that are displayed on the job board instead of every single level that you could possibly go to. You don't actually even need to you don't need to force it on Rails. You could still give students a selection, but you could give them a curated selection taken from the best options that they have at that given time. So you could still make it feel a bit open-ended. You could give like a bit of an illusion of choice thing going on.
Yeah, we had a project like that with our game Decimal Point that it had an underlying knowledge tracing model, and it recommended a set of levels, but they could still pick whatever level they wanted. And then we found that if you followed the recommendation, it strongly mediated learning. But an interesting thing about thinking about that as a structure in looking at your moments model here, if you detected, say, a moment of struggle halfway through a task, you can't actually intervene until they go back to the job.
Not with a level choice, no.
Yeah.
But that's one of the ones where we're looking at like, you know, macro scale. What is the incidence rate of struggle across these different levels?
Mm-hmm.
With the idea
you're
being
struggling now, maybe reduce the struggle down the line.
Yeah.
Kind of reminds me a lot of I don't know if you're familiar with the AI director in Left 4 Dead.
I'm not familiar with the AI director in Left 4 Dead.
It's a really clever design. There's a good GDC talk on it. I can send it to you if you want. But essentially the AI director in Left 4 Dead used a bunch of different techniques to change the level of geometry, change what kind of zombies would be showing up and stuff, to kind of modulate a level of narrative tension.
Mm-hmm.
And so you can think of a similar thing.
Alternate between like harder versus easier levels so that you kind of keep yourself in that optimal pipeline.
Yeah.
Yeah.
And that can actually be pretty light in terms of the modeling it does. I think what they did in Left 4 Dead was like there were like 4 levels of tension. And as soon as like a big horde of zombies came up, like that was 4, so the next one immediately had to be 0. And so they just had like a really basic sort of interest curve structure built into the system. And so if you could do a similar kind of thing here, if like we detect moments of tension and that like ratchets up a struggle, and that like ratchets up a struggle estimation, then we need to go for what we know is going to be a lower struggle moment in the future.
Right.
Something like that. That could be really interesting to explore with a learning angle on it.
Yeah. I mean, I think there's a lot of nuance to the question of these learning sequences in terms of like, well, how do you actually want to sequence them? Like, what do you want to, what elements of the models and detectors and gameplay features that you've built are actually the actionable ones that you want to care about? Because I don't think we've quite gotten to that step because we're still trying to build, you know, a functional model first. Right. But after that, we arrive at that really interesting question of, okay, well, now you've got, you know, goodness scores for the sake of simplicity assigned to each level. And you have a couple basic player characteristics, like, do you enjoy struggle more or less? Do you enjoy achievement more or less? And now how do you actually pair those up in a way that's meaningful? Because it's not just like, oh, recommend the level that's going to generate the least struggle all the time. Mm-hmm. Because that's not something that's going to keep you in, you know, that optimal flow state.
Right.
Also, some levels are just harder than others. Like if you're always recommending the level that has the least struggle, you're going to get to the end of the game and there's going to be like 6 nightmare levels that are all in a row. They're just like the hardest levels in the game that never got recommended because they naturally generate more struggle based on their difficulty.
Mm-hmm. Not directly related to applications, but in terms of like experimentation, modeling, argumentation, like obviously there's more synthesis involved with some than others versus like a simple experiment where you're observing things. Did you find one of those categories easier to predict or observe struggle, or you found higher instances of that between those 3 different kinds of tasks?
Experimentation was the easiest place to detect struggle, and I think argumentation had the highest levels of struggle overall. Like in terms of experimentation, modeling, argumentation, or diving. I'm pretty sure, without having the data in front of me right now, that the majority of students by a pretty healthy margin struggled in argumentation. And I think that's because if you don't have things quite right in experimentation or modeling, you can arrive at argumentation before you have the information that you actually need to succeed at argumentation. And so a lot of times that's the point where you realize that you have an issue and you start to struggle because you're like, this scientific advisor is asking for something that I have previously failed to acquire.
But you're saying you have better rates of success in predicting experimentation, despite the fact that argumentation builds off the other
Yeah.
two.
Argumentation is where most struggle happens, but it's a difficult place to predict struggle. Less struggle happens in the experimentation tank, but it's easier to identify when that struggle is happening because you've got those two clearly defined, like I'm lost and I don't know what I'm doing cases that I talked about with Erik, where you're just adding organisms that are like not from the right biome, or you're rerunning the same experiment multiple times.
Did you look at all like within session, like in your model? Could you look at like, I had a struggle moment previously. Am I more likely to like struggle now? Like to get at those kinds of the interdependency between some of the tasks, like argumentation is harder to do if you screwed up the experiment. And so if you struggle in the experiment, are you more likely to struggle in argumentation?
I don't think so, but that's a really good idea. Like struggle might be something that is trait-based instead of state-based, sort of.
I would think about it probably more as a long-term state, but yeah.
Yeah.
I feel weird about saying you're just someone who's gonna struggle with stuff as a trait. That feels wrong, but
yeah. This is harder for you.
I get
for
what you're saying. Yeah. But also, yeah, like because do you have among these tasks, are they do you know that like when they're tied together? Like is the argumentation, the experiment, the I forget what the diving thing is called. Are those distinct tasks, but they are tied together in a job?
Sometimes they're not necessarily distinct tasks. Sometimes they're actually a task will cut across different experimentation, modeling, and argumentation performances. It was actually one of the things that kept us from building like an experimentation struggle detector, a modeling struggle detector, et cetera, is because struggle can cut across multiple different scenes like that. And now I've forgotten the first half of your question. Sorry.
So if they were set up, I think I don't think I had a second half yet. So if they were set up in a sequence, you could look at like within a job, having struggled on the experimentation step of this job makes it potentially more likely that I struggle on the argumentation step of this job.
Gotcha. Yeah.
But
well, and also for there, you could look
look
across jobs too. Like if you struggled on your last job and you switched, did that switch actually work for you? Like, did you manage to mind reset, or are you just kind of like, are you playing Wake on tilt right now?
Mm-hmm. Yeah.
So like maybe thinking about that a little bit more broadly, I think, yeah, that would be a good question of was in your modeling process, was there any sort of meta information attached to, if I'm going to rate a given task, do we have any metadata indicating characteristics of that task specifically? Because the direction I can imagine taking that, if we're thinking about sequences of jobs, would be that if a given task has some metadata associated with it, let's say this task required experimentation and they struggled on this task, you could sort of loosely infer they struggled on experimentation. And then some metadata that we do have is that at least per job, we've got indicators for roughly how much or how complex that job, through all the tasks of that job, how much of each mechanic there is. And so you could imagine if we could identify struggle and say that this struggle primarily occurred on tasks that had experimentation, that could be a factor in choosing a better sequence of jobs by looking at jobs that are rated as having less experimentation or at least less complicated experimentation, and trying to adjust so that they sort of a player slopes up as they go from job to job.
Yeah, I want to say that I want to say that there is a feature that was the percent of time out of the entire task that you spent in every given room. So it's like percent time in experimentation, percent time in modeling, percent time in argumentation. I also know that there's metadata on the back end that includes things like difficulty of each room per job or something like that. So it's like experimentation difficulty for this particular job.
Yep.
We correlated against that metadata as sort of like a measure of external validity to say, yeah, this thing that we're looking at for struggle is, correlated with experimentation difficulty like 0.45. But I don't think we ever actually included that metadata as a feature.
So you're saying the struggle detector that you have right now is just purely based on behavioral data?
Yes.
It doesn't really know anything about the task.
Yeah, it's pure behavioral data.
Interesting. It's kind of surprising that is actually as good as it is.
I was surprised that it wasn't better. I figured you could tell a lot about whether a student was struggling just based on like their telemetry data.
Yeah.
We were expecting
kinda
this thing to be at like 0.75 or so.
Right. I wonder if there's a distinction. I know if there's better words for this in the learning ed tech EDM type literature. But is there like a difference between like task irrelevant struggle and task relevant struggle?
Can you say a little more?
Like I could see a lot of what EDM people call gaming the system being task irrelevant struggle.
Mm-hmm.
Or I'm just gonna like try the buttons, or like the one I'm gonna add a bunch of fish and stuff. Versus like I'm trying to do what the task wants me to do, but I'm struggling through it. Like trying to form arguments or something. I don't. It would, I guess, depend a lot on the structure of the game itself, and I don't work on this game every day, so.
Well, there's also a bit of like wheel spinning stuff that you could bring into that as well. I think wheel spinning, if you're talking about constructs that exist in the literature and are well defined, wheel spinning is probably like the one that's closest to what we're talking about with struggle.
Right, but I could see like wheel spinning. So I guess some behaviors that I could see potentially being sort of task relevant struggle would be like, I'm clearly putting in, and I'm thinking about this just in intelligent tutoring sense right now, just because it's easier to think about. But like if I'm putting in numbers that kind of like I could plausibly construct given the environment that I have, versus I'm just putting in like 1, 2, 3, 4, 5, 6, versus I'm putting the same answer in again and again and being like, why is it not right? Those all feel kind of like they could be experientially different kinds of struggle. Like one is I'm trying to engage in the task and I'm just not getting it. One is like I tried to engage in the task, but I'm just over it and can't do it anymore. And one is like I don't actually care what the task is.
Right.
I'm trying to get out of it. And yeah, I wonder if there'd be a way to think about those.
I don't know. I do know that when we originally started out on this, we recognized that there were probably like different, not even struggle, just like different things that a student can do in the platform. So we had a gaming the system label that we applied. We also had an exploration label that we applied, where exploration would be something like the student went to a dive site and they scanned every single organism, and then they came back to the ship and they put every single organism in the tank. And they just studied every single relationship that existed. They read all the entries in the bestiary all at once because they were curious about it and they just wanted to like explore the parameters of the game space. But those were so rare that we stopped coding for them. It's not that they didn't happen, it's just that they happened really, really rarely. And so I think we might get into, if we wanted to look at those different elements of what you're struggling with, we might run into a bit of that data scarcity issue again.
Mm-hmm. But I remembering where I was trying to go with even asking about that was like task irrelevant struggle. I think it makes sense. You could get out 100% off of just behavioral data. But if it was like task relevant struggle, I think you would probably need some aspect of task representation to understand if and why they're struggling.
I gotcha.
Right?
I see. Yeah. I see what you're saying.
But yeah, the data scarcity thing is interesting. How many people play Wake?
In that study, like 240 people, but these days,
Right. Yeah.
we
could open up the Open Game Data website. Right?
Yeah, I'm popping over to Open Game Data now. I was just looking at this. I think for March there were 8,600 sessions. For April there were 7,300. For May there were 8,200. That's not unique players though.
Yeah, the sessions.
So I don't know, anywhere between 2,000 to 3,500 unique players, maybe, but that's just ballpark based on like you can probably finish it in 4 or 5 sessions.
Yeah.
12-hour game, 2 hours of playtime every day.
Mm-hmm. Assuming you play it across multiple days, you're not doing it in a classroom for 45 minutes once.
Yeah.
Yeah, because it'd be really interesting to try to think about like, and maybe this is well, maybe I'm inventing a new project for you, which is supposed to be against the goals of this session. But given that these games like see these crazy numbers, like how would you determine, so if you wanted to try to avoid some of these data scarcity problems, like what would be a good way to be like, what are sessions worth trying to look at because they might contain some of these things?
Yeah, set up like some really basic if then else rules that will like capture things that are struggle-ish.
Or like a preliminary detector model that kind of sucks, but it's at least better than nothing.
Yeah.
That throws it at the humans to go through and do some coding.
Yeah.
You can do probably a lot of cutting of those. Like I'm sure a lot of those 8,000 some sessions are people who quit after like 2 minutes or something. So like there's at least some amount of filtering that can be done there. But
it's not going to be perfect, but you could cut out every job that ends in a complete job. And you could say that like, yes, struggle is likely to happen in levels that students eventually go on to complete successfully. We acknowledge that, but we're going to focus on looking at instances where struggle is so bad that a student just quit. And you might get noisy data in there as well. It might be that like it was dinner time and so you closed the game even though you were doing fine. But if you wanted to set up a couple really basic heuristics of like, let's try and get in the same general area is where struggle might be taking place. Looking at jobs that were never completed successfully might be a place to start.
I could also potentially see like one standard deviation up in completion time or something like that.
Or down.
Yeah.
If you're like hop in, struggle, this is too hard, job switch.
Oh sure. Do you have a concrete signal of job switch?
Yeah.
Okay. That's useful.
It's a explicitly defined event in the game data.
Great.
The problem is that it shows up anytime you accept a job as well. So there's like a little bit of filtering that needs to show up, but yeah, you can filter it relatively easily.
I have had many cases where I wanted that to be a feature. Because it's either you're looking for the switch message or you're looking for the start while another one is open.
Yeah.
Like managing an open close thing all the time.
Well, or you're looking at like, where does problem ID change, but there's not a correct solution in the previous problem ID. And yeah, it's the working with where job switches happen in Aqualab has been not painless, but less painful than a lot of other systems that I've worked with.
That's good, getting better at putting those log messages in. Yeah, but that would be interesting to try to look at, like, could we figure out a way to kind of like siphon off the fire hose
Yeah.
if we think there are these interesting kinds of struggle and or other kinds of, like, you can think about it for like generally for other kinds of measures as well, but like how do we occasionally tap into this data, because we're getting tons of data all the time, to try and throw it at humans and actually figure out what's going on.
Yeah. Although this is one that I need to talk about with David tomorrow, actually, is that not to go like super far off task, but we've started working on this job switch detector rather than the job struggle detector.
Mm-hmm.
We did our initial analyses of the job struggle detector on the old data that we collected in 2022. We were like, okay, job switching happens a lot. That's nice. It's like, 20, 30% incidence rate. I grabbed all of the data from March 2023 this afternoon. Well,
Mm-hmm.
not this afternoon, I guess this morning. It's only like 2 p.m. And using the exact same methodology as we did in the 2022 data, I found 10 instances of job switch in a data set that's like 15 times the size. 10 total, not like
Yeah.
10 times more. There are 10 places where these 8,600 sessions switch jobs. So it's gone from really prevalent in this 2022 data set to virtually non-existent in more recent data.
That's one of
And
those cases where I'd be like, what did we change?
I haven't been able to find it. I was in the logs trying to figure it out, but everything looks exactly the same.
And for what it's worth, a lot of things changed. So February 2023, I believe, is when like there was a big milestone release that added a bunch of like story content to the jobs, and to the overall game, and other changes that were made. So I I don't know whether things changed in the event logging, but the game changed pretty significantly from uh, 2022 to early 2023. A lot of jobs that might have been broken before, that maybe some of the people we were seeing who, were failing on a job, couldn't pass it, switch to something else. It's entirely possible that some of those jobs were just fundamentally broken and were fixed later.
That's a less exciting but more plausible story. I would be really interested. I've still got the open game data site. There's 7.8 sessions in September 2022. That's old version of the game before a lot of the narrative was in.
Yep.
Is that correct?
Yep.
How cool would it be if we could find a way to nail down, this is not struggle anymore, but it's job switch, and it's still like broadly relevant to the topic we're talking about, I think. Because the struggle might have this issue as well, where what students struggle with changes as the game gets updated. What if you just like don't struggle as much and you don't job switch as much when there's a narrative structure in the game because you're more invested in the progression through levels?
I'd actually want to look at, yeah, related to that, is there less diversity in sequence, which might actually just be the inverse of job switching, depending on how you define it. But as the game became more, that'd actually be really kind of a cool analysis / paper to write, of like, here are analytics tranches of a game in development and how behavior has changed.
That's what I'm thinking. And I was
Yeah.
also trying to figure out what I'm going to send to like EDM and ICC this year at the same time. So I think I might have.
Who wants to write a CHIPlay paper?
So we actually have a project right now, where we're doing not changes in like struggle, but we are looking at exactly that, of from basically January 2023, before this big milestone release, to February 2023, big milestone release, lots of story content added. And we are doing some analysis looking for changes in how the game was played, specifically looking for evidence of more players playing from home, as opposed to like sort of during school hours.
Mhm.
So definitely, if you've got big ideas about like things you'd want to look at for before and after, big story content, what changes might have happened. That's stuff that we're already looking at. We'd definitely be happy to uh, collaborate, chat on a regular basis around thoughts and insights and ideas there.
Yeah, that would be really interesting.
What game is that?
Oh, with Aqualab, yeah, or Wake. Yeah, I've got in my brain, this game was called Aqualab for multiple years before it got released as Wake. So now,
Mhm.
like, the names mean the same thing to me.
Well, at least you guys gave yourselves the subtitle, so
Yeah.
the game is officially Wake Tales from the Aqualab. But yeah, that would actually be really interesting to look at. Like, how does behavior change once you add narrative?
Yeah.
Of course, you probably changed a few other things too. So really, just entangling might take some doing. But yeah, I think struggle is a really interesting construct here, and switching being a sort of related thing. I wonder actually if you get the switching detector, or is the switching detector because you have a signal for switching is really
Yeah, it's just a signal.
detecting
There's no
reinforcements.
model necessary. Well, it's we know when struggle happens, and one of the things that we want to do, continuing to think about behaviors we can intervene on, is we can build a detector that predicts when you are at risk of switching, and then gives you an intervention. But yeah, the moment of job switch itself is just a signal in the data. There's no coding necessary.
Okay. Cool.
If only there was a log data event that was like student is struggling. Yes, no.
Well, we could make one.
Row by row.
Train the detector. But I think it would be interesting because I think struggling in that context is probably not like, it's not like a moment that can be a single event line in a log file, right? Maybe there's a moment in which struggle started, but struggling isn't really a moment thing. It's at least not at the level.
It's a longer term thing.
Not at the level of log analytics. Probably a couple seconds long, but it's just not an instant. And that can be difficult to work with. Did anybody tell you about the To Struggle-ish Spiel paper while you were at CHIPlay?
No, I don't think so.
That's a CHIPlay paper from a couple years ago. I can send you the reference.
Yeah, I would love to take a look.
Here's the reference. I just think it would have been funny because half the authors were there. Oh, it was an FTG paper, but yeah, it's a lot of really kind of productive failure and succession failure. What do they mean, kind of thing, but not at all thinking about LARP, which is interesting.
Okay.
But yeah, we are coming up on the hour, and that's kind of, I think, what we're going to try to settle on for the length of these things. Hopefully this was helpful, Stefan. Happy to follow up on any of these ideas.
Yeah, it was super helpful. Thanks for the help brainstorming.
And once again, to all the rest of you who are here, if you have a project you potentially want to talk about, feel free to reach out. We can get you on the schedule. Our next session is scheduled for November 1st, if I remember right. And we actually already know who it's going to be. The schedule. It will be someone from USC. And we actually don't have a note on what they'll be talking about, but they'll be coming in to talk to us about their project. So finally, somebody who's not from Field Day.
I'm not technically from Field Day.
Well, yeah, but the game was. So.
Right.
So that'll be interesting to see and hear from some other people working in this space. one thing we do want, so a couple things housekeeping wise we'll be looking at over the next week probably. I want to make sure the recordings that we take of these are getting put up there. There's a YouTube link for the first one. I think the second one was recorded from CHIPlay and was put on YouTube somewhere, and I'll track that down and put the link in. But then also trying to share the files and links and data of the different speakers and the things they've worked on, and trying to establish that as well. So, and then also look forward to a calendar invite that we will try to put up somewhere that you can actually subscribe to, so that people can remember this thing happens. But with that, I think we will close things down.
Sounds good. Thank you.
See you all on the 1st.